This is May 2012, S2, question 8. I'm going to skip straight past part A because that's quite straightforward, your regular binomial type of question. But I want to look at part B because that's a bit more tricky. Part B says, in a large restaurant, an average of 3 out of every 5 customers ask for water with their meal. Find the smallest value of n such that the probability of x being less than n is greater than or equal to 0.9, where x is the number of people who ask for water. The first thing I want to do is I just want to think through exactly what I need to do for this question. Well, because I'm given my probability and not my number in here, I know that I'm going to be using my tables backwards. So that's the first thing I know that I'm going to do. I'm going to use my tables backwards to look for a probability. However, it's not going to be that straightforward. And the reason it's not going to be that straightforward is what we can see when we look at this side of the question. I have a less than sign when in the tables I can only look up less than or equal to. That's the first problem. The second problem, which is going to be more tricky, is that my whole probability distribution is to do with the probability of 3 out of 5. Now 3 out of 5 comes out as 0.6. 0.6 is more than a half, so I can't actually look that up in the tables. So at the moment, I don't have anything I can look up in my tables. I'm going to have to change this expression here so that is something I can actually look up. So there are 2 steps that I'm going to have to do there. First of all, I'm going to have to fix n and p so that it works out, particularly p. And then I'm going to have to make my question part here of the form being less than or equal to x. So basically I've got 3 steps all in all. First of all, I'm going to fix my distribution, make n and p something I can actually look up. Second of all, I'm going to change it to the form where I can directly look it up into the tables. And then finally, I'm actually going to look it up in the tables. So let's think first of all about my distribution. I've started off with a distribution, which is x, the number of customers who ask for water. I know that my n is 50, and my p is straight from the top of the question is going to be 0.6. That's straightforward enough, but what can I say that's the opposite of that, so that I've got a probability that's lower than a half? Well, I can say the probability, my distribution is going to be the people who don't ask for water. So I'm going to define a new variable y, and that y is going to be the number of people who do not ask for water. Now, if 0.6 is the chance of asking for water, 0.4 must be the chance of not asking for water. So my y distribution is a binomial distribution where n is 50, because that doesn't change, but crucially my p is now 0.4 because that's 1 minus 0.6, so you know those probabilities have to add up to 1. So that means that I've ticked off my first bullet point that I said I'd have to do. I fixed n and p because now if I look at my tables, it is true that I have a table where n is 50 and p is 0.4. I can indeed look that up. The next thing I need to do is now change this here so that it is with a less than or equal to sign. But not only that, I need to change it from an x there to a y, because the y is the one I can actually look up in my tables. There's no good thinking about x anymore because I can't look up 0.6. So the first thing I want to do is I want to change this middle bit here into, instead of being an x, a y. So what I'm saying there is what is equivalent to having less than n people ask for water in terms of people who do not ask for water. The first thing I want you to do is have a look at this here, and I want you to see if you agree with what I've written here. This is saying that the number of people who ask for water, x, goes with this number of people who don't ask for water, y. So for example, if nobody asks for water, then I've got 50 people who do not ask for water. If one person asks for water, then 49 people do not ask for water. If 2 people ask for water, 48 people do not ask for water, and all the way up to 50 people asking for water would mean 0 people do not ask for water. That is going to be crucial for thinking through what we're going to do next. We've been asked for the probability that x is less than n. So let's say that n was 5. We've been asked for the probability that less than 5 people ask for water. So that means 4 or 3 or 2 or 1 or 0 people ask for water. What would that be in terms of y? Well, y would therefore be greater than 45, because 46, 47, 48, 49 or 50 people could not ask for water. Let's say it was 10. Let's say we had less than 10 people asking for water. That would mean more than 40 people were not asking for water. If you sit and think it through for a second, it does make sense. Now, I don't want to do it with 5, I don't want to do it with 10. What I want to do it in terms of is n. But if you look at what we're doing here, each time what we're thinking is we're doing 50, take away your x value over here. So in general, I hope you agree with me that the probability of x being less than n is exactly the same as the probability of y being greater than 50 minus n. If you don't agree with that, stop and have a think through it, because it definitely does make sense when you stop and think. Now, it's crucial that you understand that this and this are describing exactly the same thing. They are completely equivalent. So that means we know that this is greater than or equal to 0.9, which means this is also greater than or equal to 0.9. We're not changing the signs or anything, because we're saying that these two are exactly the same scenario, just one is talking about it in terms of people who are having water, one is talking about it in terms of people who are not having water, but exactly the same actual numbers apply in both cases. Now we're really getting somewhere. We've got it in terms of y now. All we need to do is change this middle bit here so that I've got a less than or equal to sign instead of this greater than sign, and then I'm there. So to do this, I'm going to think about, instead of this 50 minus n, which is quite hard to conceptualise, I'm going to imagine that instead, that was right here, in this middle bit here, I actually had a number 4. Then I would have y being greater than 4, which would be signified by this area here. So it would be 5 and everything upwards. That would be the area that would be given by this bit here. But I can't look up greater than 4 in my tables. I can only look up less than or equal to. So what would I actually have to do to find out the probability that y was greater than 4? I would have to look at this area here, which the tables can tell me. The tables can tell me the probability that x is less than or equal to 4. And then I can do 1 minus that in order to actually get the probability that x is greater than 4. Because if I do the probability of x being less than or equal to 4, that's 4, 3, 2, 1, 0. But if I do 1 minus it, that will be everything that wasn't included there. So that will be 5 and above, which is what I actually wanted. So what we've concluded there is that if I have a blob here, and I'm given the fact that I want the probability of y being greater than whatever that blob is, that is exactly the same as 1 minus the probability of it being less than or equal to that blob. So I can now apply that. So instead of having a blob, instead of having a 4, actually having my 50 minus n, which is what I'm looking for. Let's actually apply that. That means that I now am left with this expression here. 1 minus p, open brackets, y being less than or equal to 50 minus n on that side as my expression. This bit here is simply replacing this bit here. Now remember, this and this are exactly the same. All I've done is figured out a way of changing the signs so that I can actually look it up in the tables. That means that this bit here doesn't have to change at all. This bit is still greater than or equal to 0.9 because all I'm doing is expressing exactly the same quantity, exactly the same probability in a different way. I'm really, really close now. I have done the second step. I've made it into that less than or equal to form. All I need to do now is a tiny bit of rearranging and I can go straight into using my tables. So what I'm going to do first of all is I'm going to take 1 off both sides. That will leave me with negative, that probability is greater than or equal to negative 0.1. And then I need to multiply by negative 1 to get rid of the minus signs. Multiplying a negative is going to flip my sign around so that I am left with this as my final equation to actually look up in the probability tables. I've got my tables at the side here, and what I'm going to be doing is I'm going to look for as high as I can go where it's still less than 0.1. So I'm going down, 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 down. Don't stop here. This is 0.01, not 0.1. Please don't make that mistake in the exam. I'm going to keep going until I hit this point here. Okay, so here is the cusp between the one that's bigger and smaller than 0.01. I still need to be less than. So the number that I care about and the number that I'm going to be thinking about is 15, this one here. But what does that 15 actually mean? Well, don't forget what our tables are actually showing us. Our tables are showing us the probability of something being less than or equal to it. This is the biggest probability we can get where it's still less than 0.1. So in other words, that's showing us that the probability that y is less than or equal to 15, less than 0.1, that's exactly what that is. Now we can clearly see from that we've not got our answer yet because n isn't equal to 15. 15 is in fact equal to 50 minus n. We can see that straight from here. This is clearly equivalent to this. I am very, very close to my final answer now. All I've got to do is rearrange. I'm going to move n over to the other side and take off 15, and that will leave me with n is equal to 35. And that is my final answer. I'm going to go back to the question, read off what they want. They want this value of n. Well, that's clearly what I've given them. N is equal to 35. All I have to write, don't have to do any sentence to finish it off or anything. I've told them the smallest n, and I'm finished.